Let's start today with lesson 6, which is talking about the fundamental theorem of calculus. In this section, we will establish two basic relationships between definite and the indefinite integrals that we make a result of fundamental theorem of calculus. In the previous lesson, we said that if I want to integrate any function, and this is in a closed interval, we found the area of the shape by the geometry, and the area under the shape will be the integration or the integral of the function. Today now we will learn how can we solve it without geometry, without drawing the shape, because some of the functions cannot be or it's hard to be drawn. As you see here, the integration of f of x dx. First, you have to integrate the function. Then you have to evaluate it from x equal b to x equal a. So first you have to integrate, as we know before, then you have to evaluate. Let's see here now how. Let's now find the integration of x with respect from 1 to 2 dx. As I told you, the first step you have to integrate. Second step you have to evaluate. Let's now integrate first. Now what is the integration of x? It is half x squared. Then here if you have a definite, don't write plus c, because later on it will be cancelled. So keep it as half x squared. Then from 1 to 2. This one here, that's mean I integrated now, and I want now to evaluate from 2 to 1. It's like I have to find f of 2 minus f of 1. So here now it is half. Now I will integrate from 2 to 1, from the greatest to lowest. So I will say half 2 squared minus half 1 squared. I will repeat. I have here from the interval 1 to 2. So after I integrate, I have to find f of 2 minus f of 1. It will be minus, not plus, and of f of the greatest minus f of the lowest. So it will be half 2 squared minus half 1 squared. Half times 4 minus half times 1. So 2 minus half, which is 3 over 2. So the integration from 1 to 2 for x dx will be 3 over 2. Is it clear?
Yes.
Can you repeat from where we got the half?
This half here?
Yes.
Here, as you remembered in how to integration, if you have x to the power n, what did we say? We say it is x to the power n plus 1 over n plus 1. If you have x to the power 1, what did we say? We say x to the power 1 plus 1 over 1 plus 1, which is half x squared.
Okay.
Okay? So here now, as you see, in the previous lesson, if we have the integration of x, what does it mean? This is x from 1 to 2. So here, if you want to solve it without using the techniques of the integration just by find the area of the shaded shape. Here, as you see, we have the shape of trapezoid, and if we solve it by geometry, we say that the area of trapezoid is half the height times base 1 plus base 2. If we imagine that this is the base, from 0 to at 1 it will be 1, at 2 it will be 2. So imagine that this is the first base, 1, the second base, it is 2, half, times the height, 1, so it is half times 3, which is 3 over 2. So if you want to solve it by geometry, by finding the area of the shaded shape, which is trapezoid, and when you find its area, which is a 3 over 2, the another way that I told you about them, how first you have to integrate, then you can evaluate. So to find the definite integral, we have two ways: by geometry or by finding it as an indefinite integral, then evaluate. Let's have now another example. Here, the integration from 1 to 9 to the square root of x. First, 1 to 9. The square root of x, it is x to the power half. So first of all, I have first to integrate. What is the integration of x to the power half?
Half plus
It will be
plus 1
x to the power half plus 1 over the
over
new
half
exponents, which is
plus
half
1.
plus 1. Then after I integrate, I will change, or I will convert this sign to be written as this sign here, from 1 to 9. This one here, that's mean it's ready to evaluate. So now we have x to the power 3 over 2 over 3 over 2 from 1 to 9. Then we can write it as square root of x cubic over 3 over 2 from 1 to 9. And then we have cancelled, it is 2 over 3 of square root of x cubic from 1 to 9. After now, I wrote it as simplified here, 2 over 3 cubic root or square root of x cubic. Let's now evaluate. How can I evaluate here? I have to say it's 2 over 3 square root of, shall I write first 9 or 1?
1. 9.
9, bravo. It's 9 cubic minus
1.
2 over 3 square root of 1 cubic. Now, then after that, 9 cubic, that's mean I have 9 over 3, 2 over 3 times 9 times 9 times 9. Square root of 9 is 3. Square root of 9 is 3. Square root of 9 is 3. So I have 2 over 3 times 3 times 3, 9 times 3, 27. So let's write here as 27 minus 2 over 3. Then this is 18 minus 2 over 3, which is 17 and 30. So the final answer here is 17 and 30. So in the definite integral, we get it as a new expression. Here, no. Here I find in the in the definite. Sorry, we find the answer as a number. This is the difference between the definite and the indefinite here. Did you get the idea here?
Yes, teacher.
Yes,
Yes.
teacher.
Integrate, then evaluate. Let's solve now this question here. X squared square root of x dx. So here we have x squared times x to the power half from 4 to 9. Let's now simplify it. If we have two variables that are multiplied, what we have to do with the exponents?
Add.
Add them, bravo. So which is be 5 over 2 from 4 to 9. Until now, I didn't integrate. Now I want to integrate. Now x to the power 5 over 2, it will be x. Then I will add 1 to the 5 over 2 over the new
5 over
exponents.
2 plus 1.
Then since I integrated now, I have to write 4 to 9 with a new parenthesis here. Then after that, x 5 over 2 plus 1, which can be written as 2 over 2, 2 over 2. So we have x to the power 7 over 2 over 7 over 2 from 4 to 9. Then,
Teacher,
yes,
why 2 over 2? يعني plus 2 over 2, not 1.
it is 1. But I have to, when you want to add a number with a fraction, okay, we have to make them with the same denominator by multiplying. Here, what is the denominator?
Okay, with 2.
It is 2. Yes. So we say it is 5 over 2 plus 2 over 2, which is 7 over 2. Is it clear?
Yes, teacher.
Okay. Then after that here, let's continue. It is 2 over 7 square root of x to the power 7 from 4 to 9. Then it's 2 over 7 square root of 9 to the power 7 minus 2 over 7 square root of 4 to the power 7. Let's wait, I want to use a calculator here. The final answer is 588 times 2 over 7. Inshallah, and this will be the correct answer. Is it clear?
Yes, teacher.
Yes, teacher.
Let's solve now this one here. Evaluate the integrals using part 1 of the fundamental theorem of calculus. Let's solve now number 11 here first. Here we have x squared minus 6x plus 12. So let's say now, like, first let's integrate. Now what is the integration of x squared? It is x to the power 3 over 3 minus 6x 1 plus 1, which is 2 over 2 plus 12x. Then I will change the integral sign to be as an indefinite integral. Then here it is third x cubic, or you can say it's cubic over 3 minus 3x squared plus 12x from -2 to 1. Then now let's evaluate here. As we know before, we have to evaluate first with 1, then with -2. So 1 cubic over 3 minus 3 times 1 squared plus 12 times 1. This is for f of 1 minus now f of -2. That's mean -2 cubic over 3 minus 3 -2 squared plus 12 times -2. Then it is third minus 3 plus 12 minus -2 cubic, which is -8 over 3 minus -2 squared 4 times -3 is -12 plus or minus 24. Then it's like third minus 3 plus 12 plus 8 over 3 plus 12 plus 24. Then 12 plus 12, 24 plus 24, 48. 48 minus 3 is 45. And third plus 8 over 3, which is 9 over 3, or 3 plus 3, so plus 3. So the final answer here is 48. Is it clear?
Yes, teacher.
So here, as I told you, integrate, then evaluate. This is the idea from this lesson. Integrate, then evaluate. Let's solve now. Before I solve number 12, or before I will solve number 12, do you have any question here?
No, teacher.
No.
Okay. Let's solve now number 12. In number 12 here, I want to integrate 4x times 1 minus x squared dx. As you see here, we have to simplify it first. I want to convert it to the function or to the expression that can be integrated by using the distributive property. So 4x times 1, it will be 4x minus 4x times x cubic, it will be 4x cubic. From 1, from -1, sorry, to 2 dx. Then let's now integrate. What's the integration of 4x? We have 4x squared over 2 minus 4x cubic, it is x to the power 4 over 4, from -1 to 2. So now we have 2x squared minus x to the power 4 from -1 to 2. After that, now I will evaluate. So I will say it is 2 times 2 squared minus 2 to the power 4. So I evaluate first with f of 2 minus now f of -1. So I don't have space here. So I will evaluate now f of 2 minus f of -1. F of 2, that's mean I have to evaluate with 2. So that's mean 2 times 2 squared minus 2 to the power 4. And here we have 2 times -1 squared minus -1 to the power 4. Then after that, let's continue now, or let's simplify. 2 squared is 4. 4 times 2, 8. Minus 2 to the power 4 is 16. Minus now. Negative 1 squared, 1 times 2, 2. Minus negative 1 to the power 4 is 1. So it is 1 like this. Now 8 minus 16 is negative 8. Negative 8 minus 1 is negative 9. So the final answer here is negative 9. Is it clear?
Yes, teacher.
Yeah.
Yes, teacher.
Yes, Shahad.
When we write plus c.
Plus c in the definite integral. If you write it here, if you talk about indefinite, yani with there's no number, there's no negative 1 and 2. Okay, it's an open interval. You have to write plus c. And if you write it here, you can like this here. If the final answer here, where is the final? Here, write it as plus c, and here plus c, plus c. Then here we have plus c, plus c. Then it's like it comes like negative 8 plus c minus 1 minus c. So plus c with negative c cancel each other. So I have now the negative 9. If you add it here, it will be cancelled at the last.
Okay.
Okay, but from the beginning, I told you don't write plus c. So if you have only definite integral like the integration of 4x of 4x to plus 9 as an example, you have to say it is x squared, 2x squared plus 9x plus c. So this is an indefinite integral. Because why it's meaning indefinite? Because I'm talking about infinity interval. So I have to write plus c. But if you have a closed interval, like from negative 9 to 4, 4 of x plus 9, you will say it is 2x squared plus 9x without plus c. Then you have to write this parenthesis here. Is it clear?
Yes, miss.
Yeah.
Okay, now number 13 and 14, it will be your homework, and I will solve it tomorrow. This is number 13 and 14. Tomorrow, inshallah, we will talk about